Alright, so good evening. We have a problem here for center of mass considering the two-dimensional case of a uniform right triangle with mass m and height h and base b. So we have to determine a vector that identifies center of mass in terms of h and b, and also build a model of paper, cardboard, plastic, and a string that demonstrates the center of mass. Right, so we have the triangle over here, lengthen that. Yeah, it's H, it's B, is the right triangle. So considering those sides are all equal, now one way to determine the center of mass is to get the medians or bisectors. Okay, wait. Right, so the medians or the bisectors from one of the angles to the side. So get this. So we need it in terms of h and b. So we need these 2 points, and this one should be at this middle here. I think this angle. So roughly the center of mass would be around this point. Now, first we have to get the equation of these two bisectors, two medians. So first line is y equals h over 2, that's right, times x. So that's the first line. Move it around a little bit, then you will have y equals h over 2b, so which is the same as that one. Now the next line for b is y equals to h over b, so slope and x minus b over 2. Now since that is y and that is y, we can actually substitute one of these values to each other. So negative h over 2b x equals another y to h as h over b times x minus b over 2. So cancels out h leaves you with b equals 3x over 2. So we simplify that with these ones. So that would be the one of its coordinates. So we will substitute that to this actually is xr equals p over 3. So we substitute that with this one. So y equals h over 2b times x, which is 2p over 3. Cancels out. That would 1 h over 3, 1/3 h equals h over 3. So put it in vector form. Center of mass of the triangle would be 2b 3 h over 3. So these two would be the center point of the mass of triangles here, or the triangle. and those are the points of the center of mass. So next thing is we have to get two triangles, an irregular shaped one, kind of this one, and right. So next up is the two triangles, the a triangle which is this one represented with this black one and an irregularly shaped one. So as was discussed, if I put the string through the center to the center of mass of the triangle, it should be floating perpendicularly in the air. So let me just put that through. So it should be floating perpendicularly through the air, but slight margin of error, but it's almost perpendicular. So let's try another one. So another one would be this irregularly shaped one. So using this same technique, so through the center of mass here, let's get that through. Should also be floating perpendicular, almost flat, floating almost flat, which proves that the center of mass is where the object is balanced.